Welcome back, children. In the last class we have discussed inverse trigonometric functions, principal values of inverse trigonometric functions, its domain and range, and properties. Today we have to do problems based on properties of inverse trigonometric functions. So just we can rewind what are the different properties. So the first set of properties are sine inverse of sine x or sine inverse of sine theta is equal to theta if that theta belongs to the range minus closed interval minus pi by 2, pi by 2. Similarly for the next 5 functions also. Then in the second set, sine of sine inverse x, that is equal to x if x is in the closed interval minus 1, 1. Then next we have sine inverse 1 by x is equal to cosec inverse x, cos inverse 1 by x is sec inverse x, and tan inverse 1 by x is cot inverse x. Then the fourth set is sine inverse minus x is minus sine inverse x, cosec inverse minus x is minus cosec inverse x, and tan inverse minus x is minus tan inverse x. Then in the next set, cos inverse minus x, that is pi minus cos inverse x, sec inverse minus x is pi minus sec inverse x, and cot inverse minus x is pi minus cot inverse x. Then we have sine inverse x plus cos inverse x is pi by 2, tan inverse x plus cot inverse x is pi by 2, and sec inverse x plus cosec inverse x is pi by 2. After that, tan inverse x plus tan inverse y is tan inverse of x plus y by 1 minus xy. Then tan inverse x minus tan inverse y is tan inverse x minus y by 1 plus xy. Condition also important. Then next we have 2 tan inverse x. We can express in 3 different ways. 2 tan inverse x is equal to sin inverse 2x by 1 plus x square, or cos inverse 1 minus x square by 1 plus x square, or tan inverse 2x by 1 minus x square. So these are the properties. Using these properties we have to do problems. So look at the first question. Show that sin inverse 2x into root of 1 minus x square is 2 sin inverse x. X is given minus 1 by root 2 less than or equal to x less than or equal to 1 by root 2. So we have to prove this. So first we can take LHS. LHS is equal to sin inverse 2x root of 1 minus x square. Then the method is, here we have bracket, outside we have sin inverse. So we have to convert this bracket in terms of sine. So that becomes sin inverse of sine theta in that form. So we can write theta if this theta belongs to minus pi by 2, pi by 2. This is the technique. So we have to convert this bracket in terms of sine. So we can put substitution, then only we can convert this into sine. So is there any relation? If we put any substitution, can we convert this to sine function in terms of sine? So we have this result, sine 2 theta. What is sine 2 theta? 2 sine theta cos theta. Okay, here we have 2. So we put just let x as sine theta. Okay, we substitute x as sine theta. So what is root of 1 minus x square? That is root of 1 minus sine square theta, that is cos square theta, that is equal to cos theta. So this bracket becomes sine inverse of 2 sine theta cos theta. That is same as sine 2 theta. So we can write 2 theta when if this 2 theta belongs to the closed interval minus pi by 2, pi by 2. That we can check, here interval is given. So how to check that? Minus 1 by root 2 less than or equal to x less than or equal to 1 by root 2. And we put x as sine theta. So instead of this x, you can give sin theta. And left side we have minus 1 by root 2. Okay. Then apply sine inverse, or how we write minus 1 by root 2 in terms of sine. We can write it is same as sine inverse. Here just write sine inverse 1 by root 2. Okay. Here instead of sine theta, I put theta, just theta. So we have to apply sine inverse. So sine inverse of 1 by root 2. Then what is sine inverse minus 1 by root 2? That is minus pi by 4. Sine inverse range is minus 90 to 90. So if negative value comes here, we have to write negative of acute angle. So minus pi by 4 less than or equal to theta less than or equal to pi by 4. But here we have 2 theta, not theta, it is 2 theta. So multiply by 2. So here we need 2 theta. So we have to multiply. So here you have to multiply by 2, here also multiply by 2. So we get minus pi by 4 into 2 is minus pi by 2. Here also pi by 2. So look, this 2 theta belongs to minus pi by 2 pi by 2. 2 theta belongs to that closed interval. So sine inverse of sine 2 theta we can write as 2 theta. Now we have to replace theta. Since the question is in terms of x, so we have to replace theta. X is sine theta. So what is theta? If x is sine theta, then theta is equal to sine inverse x. So here it is 2 sine inverse x, that is equal to RHS. Once again children, the question is sine inverse 2x into root of 1 minus x square. We have to prove that it is equal to 2 sine inverse x. So the method is check the outside function, then we have to convert bracket in terms of that function. So bracket is 2x into root of 1 minus x square, that we have to convert in terms of sine. So we have to do appropriate substitution. So what can be this x? We can give x as sine theta. So this bracket will be 2 sine theta cos theta, that is same as sine 2 theta. So sine inverse sine 2 theta is equal to 2 theta, that is condition is there if 2 theta belongs to minus pi by 2 pi by 2, the closed interval. So we have to check, here it is given, x value is given. So we can check it already. If this value is given, this 2 theta is definitely in that range. But we can check, this is a method. So first I write minus 1 by root 2 less than or equal to x less than or equal to 1 by root 2. Then x as sine theta. Then here we need theta. So apply sine inverse. So sine inverse minus 1 by root 2 less than or equal to theta less than or equal to sine inverse 1 by root 2. And this value, principal value is minus pi by 4. Sine inverse minus pi by 4 is minus 1 by root 2. Then here pi by 4. But here we have 2 theta. So multiply throughout by 2. So we get minus pi by 2 less than or equal to 2 theta less than or equal to pi by 2. That is 2 theta belongs to this range. So we can write sine inverse sine 2 theta is 2 theta. Then you have to replace theta. That is if x is sine theta, theta can be written as sine inverse x. So 2 sine inverse x, that is the right hand side. Okay. So we proved. The second question, similar type question. Prove that 3 cos inverse x is equal to cos inverse 4x cube minus 3x. And x belongs to closed interval half to 1. So here this LHS we can't simplify. We can take RHS side, RHS part we can take. RHS is equal to cos inverse 4x cube minus 3x. Then what we have to do? We have to convert this bracket in terms of cos. So can we convert by doing substitution? We have cos 3 theta. What is cos 3 theta? Cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. So this is similar to this part. So we can give x as cos theta. So here you substitute cos inverse of 4 cos cube theta minus 3 cos theta. That's equal to cos inverse of cos 3 theta. So can we write 3 theta? This is equal to 3 theta when this 3 theta belongs to the range 0 to pi. That is the range of cos inverse function. So we can verify that. Here the value is given, half is less than or equal to x less than or equal to 1. Closed means you have to put equal symbol. Then for this x you can give this cos theta. So half less than or equal to cos theta less than or equal to 1. Then here you have to write cos inverse. So cos theta becomes theta. Here it is cos inverse 1. Now what is cos inverse of half? 1 by 2 is pi by 3. Okay, here theta, cos inverse 1 means 0. Here which is greater? Pi by 3 is more than the 0. So look children, for sine function, this 90, 0. For sine function, sine value, sine 0 is 0 and sine 90 is 1. So sine value is increasing. At the same time cos, when you think about cos 0 is 1 maximum value and cos 90 is 0. So cos value is decreasing but sine value is increasing. So here when you take cos function you have to just put the opposite sign. Okay, this pi by 3 is greater than or equal to theta greater than or equal to 0. Then we have to multiply by 3. Multiply throughout by 3. So pi greater than or equal to theta greater than or equal to 0. So is this theta is in the range? 0 is smaller one, 0 to pi. That is the range of cos inverse function. So we can write cos inverse cos 3 theta is equal to 3 theta. Then what is theta? Here this implies theta is equal to cos inverse x. So 3 cos inverse x. Is it the LHS side? Okay, that's equal to LHS. Okay, once again go through it. Cos inverse 4x cube minus 3x. Then we put substitution as x is equal to cos theta. So we get cos inverse of cos 3 theta, that is 3 theta, but you have to check it. That is equal to 3 cos inverse x. So here half less than or equal to x less than or equal to 1, x is equal to cos theta. Then apply cos inverse. So this cos theta reduces to theta. And here pi by 3, here 0. So when you take cos function you have to put greater than or equal. So pi by pi, then after this step you have to multiply by 3. So pi greater than or equal to theta greater than or equal to 0. So 0 to pi. Theta is in that range. So we can write 3 theta. Our answer is 3 cos inverse x. Now the third question. Tan inverse 2 by 11 plus tan inverse 7 by 24 is equal to tan inverse 1 by 2. So we have the result tan inverse x plus tan inverse y. Tan inverse x plus tan inverse y is tan inverse of x plus y by 1 minus xy. The condition is xy is less than 1. Okay. So take LHS part. LHS is tan inverse 2 by 11 plus tan inverse 7 by 24. So we can write in this form tan inverse of bracket x plus y, that is 2 by 11 plus 7 by 24 by 1 minus 2 by 11 into 7 by 24. I have to simplify this. Tan inverse of, so 11 into 24, here you can multiply, 24 into 2 is 48 plus 11 into 7 is 77. Then denominator part, 1 minus 14 by 11 into 24. Is this part is less than 1? 14 by a number more than 14. Definitely this value is less than 1. So the condition is correct. Now you have to simplify again. So tan inverse 48 plus 77, that is 125 by 11 into 24. Then taking the reciprocal. What is 11 into 24? 24 minus 14. So that is 250. So this we can cancel. So tan inverse 125 by 250. So that's equal to tan inverse 1 by 2. That's equal to RHS. Check it. Tan inverse x plus tan inverse y. Direct addition. We use this formula, substitute, and we get the answer. Now the fourth question. Prove that 2 tan inverse 1 by 2 plus tan inverse 1 by 7 is tan inverse 31 by 17. Here we have 2 tan inverse. Either you can split 2 tan inverse x as tan inverse x plus tan inverse x. You can do that way. So first you have to do tan inverse 1 by 2 plus tan inverse 1 by 2. Then that answer plus tan inverse 1 by 7. You will get this answer. Or 2 tan inverse x. We have another result in terms of tan. 2 tan inverse x is equal to 2 tan inverse x we can write in 3 different ways. One is in terms of sine inverse, then cos inverse, then tan inverse. So here I am writing in terms of tan inverse. 2 tan inverse x is equal to tan inverse 2x by 1 minus x square. This is the last property. So we can use this property here. LHS is equal to 2 tan inverse 1 by 2 plus tan inverse 1 by 7. That is equal to, the first term becomes tan inverse 2 into x. X is 1 by 2. So 2 into 1 by 2 minus 1 by 2 square. This is the first term. Plus tan inverse 1 by 7. So tan inverse of 2 and 2 cancel, 1 by 1 minus 1 by 4 plus tan inverse 1 by 7. So tan inverse of 4 minus 1 is 3. 1 by 3 by 4, or it is same as 4 by 3 plus tan inverse 1 by 7. Again addition formula. Tan inverse x plus tan inverse y, that is equal to tan inverse of x plus y by 1 minus x into y. Here 4 by 21, that is less than 1. Now that is equal to tan inverse of LCM 21, 7 4s are 28, 28 plus 3 is 31 by 1 minus 4 by 21. So tan inverse 31 by 21 into 21 minus 4, that is 17. 17 by 21, or we can write 21 by 17. 21 cancel. So tan inverse 31 by 17. That is equal to Okay, go through it. Here the first term is 2 tan inverse x, that we can write as tan inverse 2x by 1 minus x square. So that is the first term plus second term. So this becomes tan inverse 4 by 3, then tan inverse 1 by 7. Then again addition, tan inverse x plus tan inverse y is tan inverse x plus y by 1 minus xy. And simplification, so we get tan inverse 31 by 7. Now next one, here we have 4 functions. Tan inverse 1 by 5 plus tan inverse 1 by 7 plus tan inverse 1 by 3 plus tan inverse 1 by 8. Prove that that's equal to pi by 4. So we can take 2, take the LHS part. LHS equal to tan inverse 1 by 5 plus tan inverse 1 by 7 in a bracket. Okay. Children, you can't write tan inverse of 1 by 5 plus 1 by 7. That is not possible. That is taking out tan inverse outside. Not like that. You have to add the addition formula. You have to apply. Then the next bracket, tan inverse 1 by 3 plus tan inverse 1 by 8. Okay. Then here addition formula, tan inverse x plus tan inverse y is tan inverse x plus y by 1 minus x into y. The next bracket, tan inverse again x plus y by 1 minus x into y. Then simplify that. Tan inverse of 35, 7 plus 5 is 12. Then 1 minus 1 by 35 plus tan inverse 8 3s are 24. So numerator is 8 plus 3, that is 11 by 1 minus 1 by 24. So that's equal to tan inverse 12 by 35 into 35 by 35 minus 1 is 34 plus tan inverse next bracket 11 by 24 into 24 by 24 minus 1 is 23. 24 cancel, 35 cancel. So again you have to use addition formula. 12 by 34 plus tan inverse 11 by 23. Again tan inverse of 12 by 34 plus tan inverse x plus tan inverse y is tan inverse of x plus y divided by 1 minus x into y. Now do the calculations. Tan inverse 34 into 23 is the LCM. The numerator is 12 into 23. 12 into 23 plus 11 into 30 by 1 minus 12 into 11 by 34 into 23. The answer is given as pi by 4. Answer is given as pi by 4. So you have to get tan inverse. Which value is pi by 4? Tan inverse 1 is pi by 4. So you have to get this bracket as 1. So tan inverse. Now do the calculations. 23 into 12. Then 34 into 11. That is 650. So this we can cancel. 34 into 23. that is 782. Now what is 12 into 11 is 132. So it is 650. That's equal to tan inverse 1. Tan inverse 1 means pi by 4. Tan 45 is 1. So tan inverse 1 means it is pi by 4. So go through it. First you have to take two functions, then two functions, addition formula for first two, then next two. So we get tan inverse 12 by 34 plus tan inverse 11 by 23. Then again addition formula. So last we get tan inverse 650 by 650, that is tan inverse 1, that is equal to pi by 4, that is equal to RHS. So we prove.